Good morning, children. We'll continue with this part C, flotation. So the other day, two things. Okay, we saw the three cases, and then two main things that you have to remember. One is the statement of principle of flotation. What does it say? Weight of a floating body is equal to the weight of the liquid displaced by its submerged part. Okay, weight of a floating body is equal to weight of liquid displaced by its submerged part. And then we have the formula for, okay, we got this formula which relates immersed volume upon total volume is equal to density of solid upon density of liquid. Now basically we'll be considering the third case. Okay, a body which is uh, immersed in such a way that part of it is inside water and part of it is outside water. Yeah. Okay, now we have to find immersed volume. Okay, immersed volume means how much volume is inside water. Okay, this volume upon total volume. Total volume is the whole volume of the solid. Okay, is equal to density of, okay, so immersed volume, I write it as IV upon total volume is equal to density of solid upon density of liquid. Okay, you have to remember this by heart. You have numericals based on this and also reasoning questions based on this. Okay, so to know the immersed volume we can use this formula. Okay, now some conclusions I'm going to tell you. Okay, if I say, if I take this as a cork, okay, its density of cork is 3 by 4 gram per centimeter cubed. Okay, these densities are all standard values. Okay, if I know the density of solid, that's solid. Density of liquid, usually we use water. So density of liquid, density of water, we know what usually what density of water is 1 gram per centimeter cubed. So if I have to find the immersed volume is equal to density of solid upon density of liquid into, okay, this I'm taking it here into total volume. Okay, immersed volume is equal to this upon this into total volume. Now density of solid is 3 by 4 upon 1, doesn't make any difference, into total volume. So the conclusion is, if the density of a solid is 3 by 4 gram per centimeter cubed, then immersed volume will be 3 by 4 of the total volume. In the sense, 3/4 of its volume will be inside. So how much will be outside? 1/4. Okay, 3/4 will be inside and only 1/4 will be outside. Can you understand, children? So this formula helps us to exactly tell how much portion is inside, how much portion is outside, if we know the density of solid and density of liquid. Now, density of example, we are taking a wooden cork of density 3 by 4. Okay, less than 1. 3 by 4 gram per centimeter cubed, and liquid usually we use water. So density of water is 1 gram per centimeter cubed. These are standard values. Knowing these two, I can find immersed volume from here. The formula becomes density of solid upon density of liquid into total volume. So density of solid is 3 by 4. Anyway, upon 1 doesn't going to make any difference, into total volume. So my conclusion is 3 by 4th of its volume will be inside water and 1/4 of its volume will be outside water. Okay. Another example I'll tell you. Density of ice is equal to 0.9 gram per centimeter cubed. You know that ice will float in water. Its density is less than. So density of water is 1 gram per centimeter cubed. So when you put an ice block inside water, how much will be the immersed volume? Density of ice upon density of water into total volume. 0.9 upon 1 into total volume. So immersed volume will be 9 by 10. Okay, 0.9 is 9 by 10th of total volume. Okay, so if I submerge, if I allow ice to float in water, it will float with 90% of its volume inside water. Most of its volume. Okay, 9 by 10 means 90%. 90% of its volume inside water, and only 10%, a very small percentage, will be outside water. See, this is just 10% and this is 90%. Did you understand, children? So this is how the formula helps us to understand. If we know the density of solid, we can tell how much portion of that solid is immersed in that liquid. Okay, so the questions can be: a cork of density this is floating in water, how much part is inside and how much part is outside? So we'll say 3 by 4th part is immersed inside water, 1 by 4th is immersed outside. Cube of ice, okay, will have 90% immersed in water, 10% outside water. Okay, these are some examples. Then you have some inference or conclusions. Okay, now from this formula, immersed volume upon total volume is equal to density of solid upon density of liquid. Okay, so immersed volume is directly proportional to density of solid. Okay, if a solid has more density, when you compare solids of different density, the solid that has more density will have more volume immersed in water. Okay, so a floating body of higher density has more volume submerged inside liquid and hence experiences higher upthrust than the body of low density. Is it clear? So, if the density of solid is more, immersed volume is more. This is one conclusion. The other conclusion is immersed volume is inversely proportional to density of liquid. Now, in this case, same liquid, you're taking a same liquid, say water, okay, and in one you're putting a wooden cork, maybe a wooden cork, and the other one you're putting a rubber stopper. Okay, this will also float something, it will be like this. Okay, so when I compare these two, whichever has more density, okay, rubber has more density, so more part of rubber will be inside when compared to this. That is the first conclusion. Second conclusion, same solid you're putting in two different liquids. For example, in one you take seawater, okay, this is seawater, and in one you take river water or fresh water. You know, seawater has lots of salt, so density of seawater is always greater than density of river water. Okay, so this same wooden cork I'm immersing in both. What will happen? Immersed volume is inversely proportional to density of liquid. In a liquid of less density, more portion will be immersed. So river water has less density, so more portion will be immersed in river water. Whereas in seawater, density of seawater is more, so immersed volume will be less. So most of the part will be outside water and a small part. See, in this immersed volume is only this much. In this immersed volume is this much. Are you able to see the difference? So density of seawater is greater than density of river water. So that's how. So these two conclusions are very important. That's called inference. You can say inference or you can say conclusions. Okay, conclusions. Two conclusions. One is this one, the other one. Volume of body submerged in a liquid will decrease with increase in density. Okay. Next we go to the applications of principle of flotation. Applications of principle of flotation. First is flotation of iron ship. Okay, you all have studied this. An iron nail will sink in water, but an iron ship will float in water. You've studied in lower classes also. This is mainly because the shape of the boat is like that it has lot of air enclosed inside. So average density of boat is less than density of water. Generally, density of iron is greater than density of water. Yeah, that's why an iron nail will sink inside water. This you all know. But this boat is also made of iron. But the thing is, because of its shape, when I consider the density of boat, I should consider the material inside this also. That is basically air. Okay, so because it is shaped in such a way that it encloses more air, when I calculate the average density, it comes out to be slightly less than density of water. That's the reason why this is able to float in water, whereas an iron nail will sink in water. Okay, so first point, if you place an iron nail on the surface of water, it sinks. Why? This is because density of iron is greater than density of water. Okay, so the weight of nail is more than upthrust. On the other hand, ships do not sink. This is because ship is hollow and empty. Ship is hollow and has hollow and empty space in it, which contains air, which makes its volume large. Okay, these are the important words: hollow and empty space, in it containing air, volume is large, so average density will be small than that of water. Therefore, even with a small portion of ship submerged in water, the weight of water displaced by the submerged part becomes equal to the total weight of the ship, and therefore it floats. Now, everywhere, see, principle of flotation says the weight of the liquid displaced is equal to the weight of the floating body. See, the concept that you have to understand is how much volume will be immersed. It will submerge to that extent so when it submerges, when only this much part is inside, liquid displaced will be, volume of liquid displaced will be less. Okay, volume of only little, there will be little rise in the level. So the volume of liquid displaced will be less. Okay, so when I find the weight of the liquid displaced, that will also be less. Weight of liquid displaced will also be less. Okay, when more portion submerges inside water, that means, what does it mean? Volume of the liquid displaced will become more. It will displace more liquid so that its weight will be equal to weight of the displaced liquid. Its weight will be equal to the weight of the floating liquid. So everywhere you will see this. Therefore, even with a small portion of ship submerged, because its density is less than water, the weight of the water displaced by the submerged part becomes equal to the total weight of ship, and therefore it floats. Okay, second possible reasoning question. Under flotation of ship itself, you have so many possibilities. A loaded ship is submerged more, while an unloaded ship is less submerged. Yeah, you know that, right? If I load this, as I start loading the ship, okay, so some cargo or something, what will happen? More portion will go inside water. Why? Now, as you load it, the weight of it will increase. Okay, the cargo is loaded on a sailing ship, its weight increases, so it sinks further to displace more water till the weight of the displaced liquid equals to the, so now see, its weight has increased because I have loaded it, so it has to displace more liquid, then only the weight of the displaced liquid can be equal to the weight of the floating body. Can you understand? That is the principle of flotation, that weight of floating body should be equal to weight of liquid displaced. So, if weight of floating body increases, if this increases, then this also has to increase. Weight of the liquid displaced also has to increase. So, to increase the weight of liquid displaced, volume of liquid displaced has to increase. That means it has to submerge more. Have you understood? That is the meaning of this. Okay, so when you submerge it, it sinks further to displace more water till the weight of water displaced becomes equal to the weight of the loaded ship. If the cargo is unloaded, ship will rise in water till the weight of the water displaced balances the weight of unloaded ship. Okay, third possible question is, so under flotation of iron nail sinks, then loaded ship thing, and then a ship begins to submerge more as it sails from seawater to river water. Okay, suppose a ship was sailing in a seawater. Okay, so and then it's entering inside a river. Okay, here is a river coming and joining in the sea, and so this ship that was floating, that was sailing in this sea water, now is going inside river water. Okay, so this much is its immersed volume. This much is its immersed volume here. Now what will happen? Now, as I told you before, density of sea water is greater than density of river water. Why? Due to the presence of salts. You know, seawater has lots of salts, so its density is more than density of river water. So you remember this conclusion: immersed volume is inversely proportional to density of liquid. So if it goes from seawater to river water, it's going into a liquid of less density, so more portion will be immersed. So when it goes into river water, the observation will be more part will be submerged inside water. More part will be submerged inside water. Why? Because density of river water is less than density of sea water. So to balance it, it has to displace more liquid. Hope you understood, children. So you can simply write like this: density of seawater is greater than density of river water. We know that density of immersed volume is inversely proportional to density of liquid. So when this boat goes into river water, because river water's density is less, it will immerse more so that it can displace more liquid, which will be equal to weight of the floating body. Is it clear, children? Okay, this is seawater to river water. Now what will happen if a ship comes from river to sea? Okay, in the examination they can ask anything. Okay, now in book they have given sea to river. In homework question I have given a ship is moving from river water to sea water. What will be your observation? Give reason. So your observation will be when it moves from river water to sea water, it will submerge less. It will submerge less. Only less portion will be inside water because density of seawater is more than density of river water. Okay. First point, the water in a, here they are talking about sailing from seawater to river water. Water of river is of low density than that of sea. The density of water of different seas is also different. That depends on the salts. Okay. Okay. When a ship sails from, this is a fact, okay, that density of river water is less than density of sea water. When a ship sails from sea of higher water density to a sea of lower water density, that is seawater to river water, it sinks further. The reason is that according to law of flotation, to balance the weight of ship, a greater volume of water is required to be displaced in water of lower density. Okay, then related to the ship thing, there is another possible question, that is Plimsoll line. Have you heard about Plimsoll line? Every boat, okay, ship, a boat or whatever it is, it will have a white paint around its whole surface. Okay, that is called the Plimsoll line. Now what does it represent? Now especially cargo ships, okay, they keep loading. Now you know, initially when it was empty, when the same ship was okay, when it was empty, only less portion was submerged inside. Now, as I keep adding more and more, so immersed volume will keep on increasing. Yeah, more portion will keep on inside, keep on going inside water. Now, I cannot keep on loading it as I want, because then a level will come, a point will come when this whole ship will sink. Okay, or it can easily sink. So they would have marked a line called Plimsoll line. So whenever they load any ship with cargo, they should make sure they can load in such a way that the ship can only float till this portion. The ship should, okay, submerge only till this portion. Okay, beyond this, it should not submerge. Then that can cause this to sink inside water. Okay, so that is also based on this only. Each ship has a white line painted on its side known as Plimsoll line. This line indicates the safe limit for loading the ship in water of density 1000 kg per meter cubed. A ship is not allowed to be loaded further when its Plimsoll line starts touching the water level, so that when it sails in sea water of density more than 1000. So you know the cargo ship might have to go, see, in sea water itself, some seas, water of some seas will be more than density of, okay, for example, density of Dead Sea water of Dead Sea, okay, density of Dead Sea water will be greater than density of maybe Indian Ocean or Atlantic Ocean or whatever water. Okay, even so, every ocean, yeah, or every sea can have a slightly different density depending on the amount of salt that is inside. Okay, so you should know that. So even if a ship moves from a sea of lesser density to sea of more density, then also it should not sink inside. That's the reason why they draw this Plimsoll line. Okay, fifth one, an unloaded ship is filled with sand at its bottom. Okay, suppose so this brought in cargo, okay, from some place, from Egypt to India. Okay, now this has to go back to Egypt. Okay, now so it has unloaded everything, so it won't go completely empty. They will at least, okay, load something. There should be some weight. If it is too light, can you imagine, it will be so unstable. It will displace very less liquid because only small portion will be inside water. It will displace very less liquid, and it can easily submerge. The whole thing can topple over. It can easily topple over. To prevent that, usually they don't send it empty. At least some sandbags they keep too. Okay, so an unloaded ship floats with very less volume inside water. That's the main thing. Unloaded ship floats with very less volume inside water. There is a danger that it may get blown on by strong winds. Therefore, unloaded ship is filled with sand called ballast at its bottom. This lowers the CG to make it equilibrium. Hope you've understood all this. So there are 5 applications related to ships. Okay, the next one is flotation of human body. Okay, you know, some people can swim with very less effort. Okay, they can even float in water. You can see them float in water, but you know that density of human body is greater than density of water, so it should sink. Okay, how are some people able to float in water? So that's a technique. They have to do something for that. So why are some people able to swim with very less effort? Okay, so in this you should understand, when we think of density of body, we think of only the bones and muscles and all that, and we think it's heavy. But our body has so many things, you know, like blood, okay, air in the lungs, okay, bone, muscles, fat, okay, fat, everything. So the average density of human body, okay, this value you have to remember, is with empty lungs. Human body, okay, density of human body is equal to 1.07 gram per centimeter cubed. This is with empty lungs. If your lungs are empty, those of you who know swimming, you know that if you can fill your lung with air, okay, if you can just hold on air inside, then you know what will happen? The density of your body will decrease because air's density is less. So you know what will happen? It will become nearly equal to, this is 1.07. So if I can lungs with air, if I can fill my lungs with air, then the density of my body will become nearly 1 gram per centimeter cubed, which is nearly equal to density of water, because density of water is also 1 gram per centimeter cubed. So a person with his lungs filled with air will be easily able to float in water. Okay, so that is the technique they use. They try to fill their lung with as much as air possible so that their density becomes less than density of water. Okay, the first point you have to mention is average density of human body depends on its constituents like bone, blood, muscle, fat, etc. It also depends on amount of air in our lungs at that time. Okay, so you can start from here. The average density of body with empty lungs is 1.07 gram per centimeter cubed. You have to remember this. While the lungs filled with air is with lungs filled with air, the density value is 1 gram per centimeter cubed. That's the first point. So a good swimmer can float on water like a floating object with his lungs filled with air and nose and mouth projecting just above the water. Now the weight of water displaced by him is nearly equal to his own weight, so he can swim with less effort. Okay, you need not write this, you start your answer from here. Average density of a body. Okay, there can be another under flotation of human body itself. There's another possible question, that is, it is easier for a man to swim in sea water than in fresh water. So whenever there is a comparison of sea water and fresh river water, so what you will know, density of sea water is more than density of river water. So in river water, density of liquid is less, therefore immersed volume will be more. Okay, in sea water density of liquid is more, so immersed volume will be less. So whenever immersed volume is less, it's easy to float, it is easy to swim. If more portion is going to be immersed, then you need to every time to move ahead, you need to apply so much force. Okay, that's the reason. Due to presence of minerals, density of seawater is more than density of fresh water. That you know. Therefore, with a small portion of body submerged in seawater, the weight of water displaced becomes equal to the total weight of the body. While to displace the same weight of fresh water, a large portion of his body, okay, basically because the density of liquid is less, more part has to be immersed, then only the weight of the liquid displaced will be equal to the weight of the floating body. Okay, in a liquid of more density, less portion will, it's enough for less portion to be submerged, so that less volume of liquid displaced is less and weight of liquid displaced also is less. Okay, because already density of water is more. Okay, then again another possibility is in a Dead Sea. It seems it's very easy to swim in a Dead Sea. A man can easily swim in Dead Sea. Why? Because its density, its salt content is so high, the density of water is much more than. Okay, so I think with this I will stop now. Thank you, children.